In this lesson, we are going to look at the linear motion, and this is the movement of an object from one position to another position in a straight line. Now we can also define the word motion. Motion is the process of moving or changing position. Now, before we look at some calculations. First, let's look at the two quantities that we have to know. So the first quantity, we have the scalar quantity, and the second quantity is vector quantity. So now a scalar quantity is just a quantity with magnitude d only. So the quantity that has the magnitude, or that tells us the size, that is what we call the scalar quantity. Now for a vector quantity, we are looking at a quantity that has both magnitude and direction. So whenever we are looking at the movement and we have been given the direction where an object is heading to, we have what we call the vector quantity. Now if you are looking at the movement without being given the direction where the movement is taking place, we have what we call the scalar quantity. Now let's look at some examples of scalar quantities. So the first example we can look at, let's say if we have temperature. So temperature is an example of a scalar quantity, because if we can say that an object has a temperature of 20 degrees Celsius, we can see that the 20 degrees Celsius tells us the magnitude, the size in terms of the energy possessed by the particles that forms that particular object. But we are not being given the direction, so it can't make sense if we are to say an object has the temperature of 20 degrees Celsius east. That cannot make sense. So therefore we are saying temperature is an example of a scalar quantity. Now for a vector quantity, let's say we have like force. So force is an example of a vector quantity, because whenever we apply a force to an object, maybe let's say we have an object that is stationary and a certain force is applied to that stationary object, we are expecting that object to move. So that force that has made that object to move, it is its magnitude. Then there will be a direction where an object will move. So that is an example in terms of a vector quantity. Then the second quantity in terms of scalar, we have the distance. So distance is a scalar quantity, while displacement is a vector quantity. So now, how is distance differ from displacement in terms of or we can say apart from having direction and the other one not having the direction? So for a distance, we can say if we have a statement that is stating that an object moved from one point to another point and covered a length of 20 meters. So there we can see that we have not been given the direction where an object was going to. So we have just been told the distance. So that is just the distance, because we don't know if that object was heading east, west, north, or south. So that is why distance is an example of a scalar quantity. Now for displacement is an example of a vector quantity, because for this one there should be the magnitude and also we need to have the direction. For an example, a statement that is looking at the displacement will state like an object moved covered 20 meters from one position to another position. Then we are going to be given a direction, maybe east. They will say move from point A to B east, or from point C to D west. So as long as the direction is given, That is what we are referring to as the displacement. Now, the other thing we need to look at about distance and displacement. Distance is always positive, but for displacement it may be negative, depends on the direction given. For example, let's say we have the initial position A and another our final position B. Then the length in between A and B is 15 meters. Then if let's say we have another point C but in an opposite direction, then this point C, the distance or length between B and C is 5 meters. Now, if an object moved from point A to B and now to C, if the question was find the total in terms of distance, the distance will be 15 meters plus 5 meters. So for distance, you need to find the sum of each party. So here we are expecting to have a distance of 20 meters. Now, for displacement, so for displacement, let's just have x to represent the displacement. So for displacement, if we choose A to be as positive, then the opposite direction, if we move opposite of A to B, we are going to have a negative. So what we are saying is for displacement here, we need to have the first t, which is our 15 meters, minus 5 meters. So we are going to subtract, and the reason is because the other 5 meters is moving in an opposite direction as to 15 meters. So we are going to subtract, so we can see that the displacement is 10 meters. Now, so this displacement now is defined as the change in position. So if an object moves from point A to B and to C, the only change in position, this object we can say is moved from A to C. That is the position we are interested in. So we are not interested in where the object moved, it passes, it makes sense, as long as if we just consider the initial and the final. So the initial position, our initial is A. Then our final is C. So for displacement, we just consider the distance from the initial up to the final. Then for distance, we need to consider each party that was covered. Okay, let's maybe have another illustration. Okay, so let's say we have point A, but this time we are going to say an object or a person moved in a circular manner to point B. So if we say here, let's say this semicircle here, we can say maybe we have 20 meters. Then this diameter, the line from A to B, this represents our displacement. So displacement, we are just looking at the straight line. So it has to be the straight line from the initial. Our initial is point A, our final is point B. So for displacement, you just consider the initial position and the final position. Now you need to draw a line in a straight line. So regardless how this person or an object moved, we just have to consider the straight line. So this line in green, this is our displacement. But for distance, we just have to look at where this object moved. So our distance is denoted by this semicircle of 20 centimeters. So if the question was find the displacement under this party, we need to just find the diameter of this semicircle, because that will denote our displacement. Maybe let's also have another illustration. So if maybe a person starts from this point, moves, and then he ends at point B. So as we can see, our initial is point A, our final is point B. Then let's say the distance that was covered along this line we can say we have 50 meters. Now, if the question was to, like, if we are to consider the displacement will be the distance from the initial to the final, but in a straight line. So this line in green denotes our displacement. So I'm sure now we have a picture on the difference in terms of displacement and distance. Now, there are times where the displacement may be equal to the distance. So in a situation where an object moves in a straight line without making any turn, so we can say our A and our B. As usual, this is our initial point, then this is our final point. So now if the length between point A and B is 10 meters, and if you are like asked to find what is the distance covered, our distance covered will be 10 meters. Then what also is our displacement? Our displacement will be also 10 meters. So therefore, the similarity between these two, the distance can only be equal to displacement if an object moves in a straight line without turning. Now, away from there, let's have another point. Away from there, let's say an object moves from point A to B. Then again, this object or person turns and moves in an opposite direction now from B back to A. Now, if the first question that we can ask ourselves is, what was the distance? So here, the distance now, we need to add the two distances. The first, the one that is indicated the going, and the one that indicates the coming back. So we can say 10 meters plus 10 meters. So our distance will be 20 meters. And remember, we said distance is always positive. Now for displacement here, the object moved from A to B and back to A. So the displacement this time is 0. So what we are saying is, what you need to have in mind is, if an object moves from one position to another position and back to the original position, the displacement is always 0. Why? Because we defined displacement as change in position. There is no change in position since an object has returned to its initial position. Or if you want to show mathematically, we said one direction must be positive, then the other direction must be negative. So we can say 10 meters from A to B will be positive, minus the other 10 meters from B back to A, which is negative, since we are moving in the negative, opposite direction. So 10 minus 10, we have our 0. So the negative here tells us that an object is now moving in an opposite direction as to the first direction. Now from there, let's look at the other two. Let's look at the speed. So look at speed, then the second one we'll look at velocity. Okay, so the velocity can be found by calculating so we need to have the displacement divided by the time. Then for speed we need to have distance, then divided by time. The symbol for speed is S. Then we have d for distance over t for time. Then for velocity we have v. Then for displacement, it depends with maybe the book that you are using. So in some books you may find x or s. So we can say x divided by our t. Now the first difference between the speed and the velocity is the speed is a scalar quantity, while velocity is a vector quantity. So that is the difference. So therefore, if we say an object moved from one point to another point with a speed of 30 meters per second, so we can see that we have only been given the magnitude. So we can say if we have maybe the speed of 30 meters per second here, so we can see that this was just a speed. We have not been given the direction. We don't know the direction in which an object was moving to. So here this is now a vector quantity because there is no direction. Now for a vector quantity such as velocity, if we say an object moves with velocity of 30, let's say meters per second, we need to indicate the direction. Let's say it moves 30 meters per second east. So as long as we have been given the direction, we are dealing with what we call a vector quantity. Now these two, the speed and the velocity, are measured in the same SI units. They are all measured in meters per second. So the only difference, one is a scalar, then the other one is a vector quantity. Now let's look at what it means by 30 meters per second. So what this means is if an object is traveling with a speed of 30 meters per second, it means that per second, for 1 second, an object is covering a distance of 30 meters. So meaning if we have another second, meaning for, let's just say for another second, we are expecting to cover another distance of 30 meters. Another second, we are expecting to cover another distance of 30 minutes. So meaning after 3 seconds, we are expected to cover a distance of 90 meters. So therefore, the velocity or the speed tells us how fast an object is moving, or how much in terms of the distance or displacement is being covered in a certain time. Now, so from there, we've looked at in terms of quantity. We've also looked at in terms of the symbol between speed and velocity. Then we also looked at the units in terms of speed and velocity. Now, let's have an example. Okay, so now an example, the first example, a girl started at point A, walked 5 meters south to point B, turned 90 degrees and walked to point C, which is 12 meters to the west, and the total time elapsed from A to C is 5 seconds. The first party, what is the girl's total distance? B, we are looking for total displacement. C, we are going to calculate the average speed. Then our D, we look at the average velocity. So the first part that we are going to do is we need to come up with a diagram to give us a picture of how this girl moved. So first we need to have, we know the compass. So at this point, this is where our east is, our north, west, then we have our south down there. Now, so let's say this is our point A is here. This is our point A. So point A indicates the initial because this is where the journey started. Then we have been given a girl started at point A, walked 5 meters south to the point B. So since we are moving in a direction toward the south, we are going to draw a line from point A in a straight line toward down, since we are looking at the movement in a south direction. So we have this one. So to point B. So let's say this is our point B and we have been given 5 meters. So the distance between A and B was 5 meters and turned 90 degrees. So after turning 90 degrees, this girl now went to the west. So west, now we are going to move in this direction. So this is where our point C is. So our point C denotes our final destination, and the distance between B and C is 12 meters. Then, since their turning was 90, so we need to have an angle of 90 here. So this is an illustration of how the journey took place. Now, for the first party, question A, which is we need to find the total distance. So the total distance now will be just the distance, the sum of the distance between A and B and B and C. So we are going to add the first distance of 5 meters plus the other distance of 12 meters. So if we add, we can see that we get 17 meters. So this is our total distance. So in terms of distance, we need to count every party that was covered by that particular object, but in our case, girl. Now for the second party, which is the total displacement. So the displacement, we said we need to look at from the initial to the final, but in a straight line. So this now line from A to C, this is now our displacement. So now we need to find a displacement. So displacement, we are not interested in terms of where he went and makes the turn. We just have to consider the straight line from the initial position to the final position. So we want to find this distance. So now what we are going to do is, we can see that we are dealing with a right angle triangle, and we can see that we have been given the two distances, and we are looking for the third distance, which is our distance x. So we are going to use the Pythagoras theorem. So here, from the Pythagoras theorem, the longest distance is known as the hypotenuse. Then the other two distances, 5 meters and 12 meters, are known as the adjacent. So what we are going to do is, we are going to use the formula for Pythagoras, or the concept. So we need to begin with the one for hypotenuse. So the hypotenuse is AC. Now you square it. So AC squared is equal to AB squared plus BC squared. So we can see that when we square the two distances and we find the square root of the sum of the square of the two distances, we have the distance for hypotenuse. So we can now continue. We have AC squared is equal to our AB. The distance from A to B is 5 meters. So just say 5 times 5, since it's squared, plus for BC we have our 12 meters multiplied by another 12 meters. So 5 times 5, we have 25 meters squared, plus 12 times 12, we get 144 meters squared. AC is equal to 25 plus 144, we get 169 meters squared. Now, since we are just looking for AC, we can now find the square root of 169. So the square root of 169, the number that we can multiply by itself to give us 169, that is 13. So therefore, the square root of 169 is 13. So our distance here is 13. So we can say now our our x, which is displacement, is equal to 13 meters. Okay, now we can move on to the other part. Calculate the average speed. So we said speed is equal to total distance divided by time taken, or time elapsed. So we can see that the distance we calculated was 17 meters divided by the time we have been given from the equation. We have 5 seconds that was covered. So 5 into 17 is 3. Remainder 2. 5 into 2, it can't, so we put a decimal. then we add the 0. 5 into 20 is 4. So the speed was 3.4 meters per second. So for every second, a distance of 3.4 meters was covered. Now let's look at the last part. So here we are going to find now velocity. So this one is equal to displacement over time. So displacement, which is x over time. Then for displacement, we said was 13 meters divided by, now time is 5. So 5 into 13 is 2.6 meters per second. So this is how we can calculate the distance, displacement, speed, and the velocity. That's it for this video. Thanks for watching, and remember to subscribe and share with families and friends.